In the last videos, we discussed about how to find a probability or how to find the area under a standard normal curve and under any normal curve, right, with different mu and different sigma, right? Here in the standard normal curve, we call the G curve, right? The mean is always 0 and sigma is always 1, right? But in any normal distribution, mean can be different from 0 or a standard deviation can be different from 1. That we call x, we denote by x, right? And we find out how to use calculator to find out the area under a curve or left to some number or right to some number. All those kind of things we discussed in the last videos, right? Now, so if the distribution or if the data is normally distributed, then we can use calculator to find out the area or the probability under a normal curve. But how do we know if the data is normally distributed or not? If the data has a normal distribution or not, okay? So to determine whether the data is normally distributed or not, there are many methods. One of the simplest method is the histogram, okay? So what we do, we write the data in the group distribution, okay? So it will be class and then frequency, right? 0 to 10, 10 to 20, 20 to 30, and so on. You continue that way and then write the frequencies. How many data are between 0 to 10? How many data are between 10 to 20, and so on, right? And based on that, what we do is you draw the histogram, right? 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. And then you look at if the distribution, if the histogram is bell-shaped, then we say that this is normally distributed. This is the simplest way, but you need to draw the graph for this, right? But there is another mathematical way to find out the normality of the data, okay? So that is called the Pearsons coefficient of skewness. There are many other methods, but we will discuss only this one here. Pearsons coefficient of skewness. What it says is, it will find out the Pearsons coefficient by using certain formula, okay? And then it will decide whether the distribution is left skewed or right skewed. If the distribution is not left skewed or right skewed, then we call that it is approximately normally distributed. Also, we make sure that there are no outliers, okay? Because outliers sometimes play a big role to show the distribution is not normal, okay? So we also find out outliers, and we try to get rid of the outliers usually. If there is any outlier, we remove that outlier and then we find out the normality of the data, okay? So we check for outliers and we also find out the Pearsons coefficient of skewness, okay? Determining the normality, okay? So the statistical method people use is find the Pearsons coefficient of skewness, or also called Pearsons index of skewness. And to find out that, we use this formula: 3 times the mean minus the median divided by the standard deviation, okay? And we find out this value here, and if the value is outside -1 and +1, then we conclude that the data are significantly skewed. If this value is less than -1 or equals to -1, or greater than +1 or equals to +1, then we call significantly skewed. But if this value is between -1 and 1, then we call it is not significantly skewed, okay? And then we conclude that the data is approximately normally distributed, okay? Also, the data should be checked for outliers. Generally, any data that lies 1.5 times Q3 minus Q1 below Q1 and 1.5 times Q3 minus Q1 above Q3 are considered outliers. We will see one example, then things will be clear, okay? Let us look at this example. Determine if the following data is approximately normally distributed. So I want to find out all those Q1, Q3, median, mean, and standard deviation using the calculator, okay? How do I do that? It is exactly same method as we did in chapter 3. You remember how do we find out the mean, median, mode, standard deviation, all those things? This is what we use, okay? What we do is we enter all these data in your calculator. How do I enter this data in your calculator? That is the thing. So what you do is go to the stat, okay, and then edit, hit enter, and in L1 or L2 anywhere you enter the data. You enter 5 and then hit enter, and then 29, hit enter, 34, 44, and so on. You enter all the data. Okay, you see that? You enter all those data. The biggest data is 158, right? 158 is the biggest data. After you enter the data, what you do is go to stat and then calc and one variable status, hit enter. So the list means the data is in L1, right? If you enter the data in L2, you should pick L2. How do I pick L2? You just do second and then 2 is L2. Okay, since all the data are entered in L1, I just list in L1. Frequency list, there is no frequency, that's why I didn't pick anything, and calculate. Hit enter. You get X bar is 79.5. SX is the standard deviation is 40.5, right? That is the SX is 40.5. So what are next values? Q1 is 45. Q1 is 45. Q2 is same as median, which is 77.5, and Q3 is 98. I found all those things. So now I want to use formula to find out the PC. So how do I find out PC? PC is the Pearsons coefficient of skewness, right? So PC, the formula is 3 times X bar minus median divided by standard deviation, right? Standard deviation. So how do I do that? Is 3 times X bar is 79.5 minus median is 77.5, right? And then divide by standard deviation is, you get, what is the standard deviation we got? Is basically 40.5. If you use that, you will get 0.148. That's what you get, right? This is less than 1, right? You see that? This is less than 1 and it is greater than -1, right? Because what it says, if the value is outside -1, meaning less than -1 and greater than 1, then it is significantly skewed. But this value is between, so PC is less than 1 and greater than -1, meaning it lies in this interval, right? So not significantly skewed. Not significantly skewed. You see that? That is not significantly skewed. Also, let us find out the outlier. What is Q3 minus Q1? Q3 minus Q1 is basically 98 minus 45. Okay, that will be how much? 53. 1.5 times 53 will be 79.5. So any data that lies below Q1, that is 79.5, smaller than Q1. That means any values that are less than 45 minus 79.5 is this 79.5 below Q1, right? And greater than 98 plus, that is Q3 plus that value. Any value bigger than this and any value smaller than this will be outlier, but there are no such data that is smaller than this or greater than this. So there is no outliers. So what we can conclude from here is this data is approximately normally distributed. Okay, so this data is basically approximately normally distributed because the Pearsons coefficient of skewness is between -1 and 1. Also there is no outliers. Usually if you find this is greater than 1, if the Pearsons coefficient of skewness is greater than 1, and then you check for outlier and then you remove the outlier and you find out again X bar, MD and SD. Okay, you do that and then find out that value. That's what you do. But since the Pearsons coefficient is less than 1, also it is better to check for outliers. If there is any outliers, remove the outliers and then find out the X bar, MD and SD again and then plug in into that formula and then check the values. Okay, and as I mentioned, I can draw the histogram of these data. How do I draw the histogram of this data? To draw the histogram, you need the class boundaries. You understand? You need the class boundary. To find out the class boundaries, first of all, we need the class limit, right? How do I do that? What is the highest data? Highest data is 158, right? What is the lowest data? Lowest data is 5. Lowest data is 5. You understand? So how do I find out the, now I need to decide the class width. Okay, suppose I want to make 7 classes. Now how do I find out the class width? Is highest minus lowest over number of classes, right? That will be 158 minus 5 divided by, I want to make 7 classes. Okay, so how much would that be? 153 over 7. That will be approximately 22. 22, right? Now, how do I draw the, how do I find out the class limit? The lowest class should start from 5, right? 5 through, so 22 plus 5 minus 1, how much would that be? 22 plus 5 minus 1 will be 26, right? And then 27 through, so just add 22 on that, so that will be 48, right? And then so on, just add 22 on this, add 22 on this. Just find out all those numbers and write out how many data values are between 5 and 26. How many? So let's say between 5 and 26 is just 1. Okay, 27 and 48 including, these are the class limits, right? So from the class limit you can find out the class boundaries. I mean, you can find out the class boundaries like, let me find out the class limit first. Class limit is subtract 0.5 from here, so 4.5 through 26.5, right? And then 26.5 through 48.5 and so on. Now how do I find out the frequency? To find out the frequency, count how many data are between 4.5 and 26.5 or 5 and 26 inclusive. Okay, that is only one data. Now how many data are between 27 and 48 or 26.5 and 48.5? That will be 1, 2, 3, 4. And then write out like all this. Okay, now after you do this, what you do is draw the histogram. So there is 4.5, you write the class boundaries here, right? 26.5, 48.5 and so on. Write on that, and these are the height of the rectangles in the histogram, right? 1, so 1, maybe this is 1, 2, 3 like that, so this will be 1. Another is 4, and then continue that way. Okay, what do you get? And then if you see that this is approximately the bell shape, then you can tell that this is the approximately normally distributed. Okay, there are more sophisticated method to determine the normality, which is beyond the scope of this course. Okay, so if you take the another stat class above this, then you will see more method on the determining the normality of the data. Okay guys, thank you.